So we are discussing hydrolysis of salt. Lysis means breakdown. So when salts break down in water, the ions will interact in a different way with water, and this phenomenon is known as hydrolysis of salt. In class 10th, we have already discussed about the pH of different types of salt. If the salt is of a strong acid and a strong base, the pH is 7, like NaCl, which is made up of a strong acid, that is HCl, and base, that is NaOH. Both are strong and their pH is nearly equals to 7. Similarly, the salt of strong acid and weak base, that is NH4OH, and strong acid, that is HCl, which produce ammonium chloride, and their pH is less than 7. Similarly, the salt of weak acid and strong base, weak acid, that is acetic acid, and strong base, that is NaOH, they produce sodium acetate, whose pH is greater than 7. And another one is a salt of weak acid and weak base, whose pH would be determined by their values of Ka and Kb. Here the example is in ammonium carbonate. The NH4OH is the weak base, while H2CO3 is a weak acid. So what actually happens, these cations and anions which are formed by the ionized of the salts, they either exist in their hydrated ions, like sodium chloride dissociates to form sodium ion and chloride ion. They exist in their solvated state, or in case of water, in hydrated state. But in case of weak acid and weak base, the salts produced by this weak acid and weak base, their ions will interact with water and form this weak acid and weak base in an equilibrium. Like the first case is hydrolysis of salt of strong acid and weak base. So previously the example was ammonium chloride. The ammonium chloride is made up of HCl, which is a strong acid, and NH4OH, which is a weak base. So if we dissolve NH4Cl, it will produce NH4 plus and Cl minus ion. If the concentration of NH4Cl is C, so it will produce the concentration C of NH4 plus and concentration of Cl minus, that is C. So out of these two, the Cl will remain in the solvated form, while this NH4 plus will interact with water and create another equilibrium in which it will produce this weak base. So NH4 plus water will give NH4OH and H plus ion. So initially this concentration was C. So at equilibrium, a small amount of NH4 plus ion will dissociate in presence of water and will produce NH4OH and H plus ion. This H plus ion is responsible for the acidity of this salt solution. So if this is C whole into 1 minus S, that is the CH amount of NH4 plus ion react with water to produce NH4OH, that means it will produce CH concentration of NOH and CH concentration of H plus ion, or we can say NH4 plus combined with 2 water molecule to produce H3O plus ion. Both are same, and here H is the degree of hydrolysis. Again, the hydrolysis constant, that is Kh, can be written as NH4OH into concentration of H plus ion divided by concentration of NH4 plus ion, which is equal to C square H square divided by C whole into 1 minus H. When H is much more less than 1, that means 1 minus H is nearly equals to 1. So it will be C, and the value will be CH square. Again, here there is H plus ion. We can multiply the OH minus ion and divide the OH minus ion. This value will give the value of 1 by Kb, and this value will give the value of Kw. So we can say Kh is equal to Kw divided by Kb. Again, Kh is also is equal to Ch square. So we can say Ch square is equal to Kw divided by Kb. So H, that is degree of hydrolysis, is equal to the square root of Kw divided by Kb divided by C. So what is the concentration of H plus ion? Here we have written the concentration of H plus ion is Ch. So the concentration of H plus ion is equal to C into H. Putting the value of H, we will get the square root of C into Kw divided by Kb. And we know pH is negative logarithm of H plus ion, which will be negative logarithm of C into Kw divided by Kb to the power half, that is square root. So it will be minus half of log C plus log Kw minus log Kb, and we all know at 298 Kelvin the value of Kw is equal to 10 to the power minus 14. So it will be minus half of log C in plus log 10 to the minus 14, and this is pkb. We know pkb is equal to minus log of kb. So this is pkb is equal to again minus half, this will be minus 14, and this is pkb. If you take this minus 14 to outside, it will be plus 7, and remaining that is minus half of log C plus pkb. So overall we can see the pH will be less than 7 because 7 minus something. So we can remember the formula pH is equal to 7 minus half of log C plus pkb. pkb because the base is weak base. So when there is a salt of weak base and strong acid, the pH is less than 7. So the value must be 7 minus something. As the base is weak, so the formula will be pH is equal to 7 minus half of log C plus pkb. Yes. So coming to the next, hydrolysis of salt of weak acid and strong base. So here the base is strong, that is NaOH, yes or no, and this is weak acid, that is CH3COOH. So when we dissolve CH3CO in a sodium acetate ion, it will produce acetate ion and sodium ion, out of which this sodium ion will remain as solvated. It will not interact with water, but this CH3CO minus will interact with water to produce and remain equilibrium with acetic acid, and it will also produce this OH minus ion, which is responsible for the higher pH of this salt solution. So if the concentration is C at equilibrium, this will be C whole into 1 minus H, and the amount of acetic acid and the amount of OH minus ion produced, this will be CH. So again, if you write down the value of hydrolysis constant, this will be concentration of CH3COOH into concentration of OH minus ion divided by concentrate of acetate ion. This will be again CH square, where H is very less than 1, that is 1 minus H is nearly equal to 1. So again, multiplying H plus ion and dividing H plus ion, we will get this as 1 by K and this as Kw. So we can say this Kh is equal to Kw divided by K, which is equal to Ch square. So what is the value of H? H will be the square root of Kw divided by K into C. So what is the value of the concentration of OH minus ion? The concentration of OH minus ion at equilibrium is equal to C into H. So putting the value of H, we will get it is the square root of Kw into C divided by K. So we know the POH is equal to negative logarithm of OH minus ion. So putting the value of the concentration of OH minus ion, we will get minus half of log Kw log C minus log A, and we know pka is nothing but minus log Ka. So this will be pka, and this is log C, and we all know at 298 Kelvin the Kw is equal to 10 to the power minus 14. So again this value will be minus and minus, that will be 7, and this will be minus half of log C plus pka. Yes or no? but we have to find the pH. So what is pH? pH is equal to 14 minus pOH, because we know again at 298 Kelvin pKw is equal to 14, and again pKw is equal to pH plus pOH. So what is pH? pH will be pKw minus pOH, or we can say this is 14 minus pOH. So pH is equal to 14 minus pOH. 14, and putting this value we can get this will be 7 plus logc and plus pk. So again here the pH is greater than 7 because it is weak acid and strong base. So we are getting a value 7 plus something, that is the pH is greater than 7, that is 7 plus something. So we can remember it easily, pH is equal to 7 plus something, and previously it was pkb because the base was weak, but here the acid is weak. So we can say pH is equal to 7 plus half of log C plus pka. So the last one, that is hydrolysis of weak acid and weak base. Like this is ammonium acetate. This is the salt of acetic acid and ammonium hydroxide, which are weak acid and weak base. So this will produce acetate ion and ammonium ion. Obviously this is a salt and this is a strong electrolyte. So if we dissolve a concentration of C, it will produce C concentration of acetate ion and C concentration of ammonium ion. But here both the ion will interact with water to produce weak acid and weak base respectively. So when acetate ion and ammonium ion interact with water, it will produce acetic acid and ammonium hydroxide. So if the hydrolysis constant is H, so this will be C whole into 1 minus H, and again this will be C whole into 1 minus H, and the amount of acetic acid and the amount of sodium ammonium hydroxide, that will be CH. So again using this equilibrium constant, if we write down the value of kh is equal to concentration of CH3COH into concentration of NH4OH divided by concentration of acetate ion into concentration of ammonium ion. Again putting the values, C square H square divided by C square whole into 1 minus H square. But we know our H is very less than 1. So 1 minus H is nearly equals to 1. So putting this as 1, this will be H square. So again multiplying H plus and OH minus ion and dividing the H plus and OH minus ion, this will give 1 by K into 1 by Kb, and this is Kw. So we can say Kh is equal to Kw divided by Ka into Kb, and this is nothing but H square. So what is the value of H? H will be square root of Kw divided by Ka into Kb. But we have to find the pH. But we know what is Ka. Ka is equal to acetate ion concentration into H plus ion concentration divided by acetic acid. So we can say the concentration of H plus ion is equal to Ka into CH3COH divided by concentration of acetate ion. So this is nothing, we can put the value of acetic acid and acetate ion from this equation. The concentration of acetic acid is CH and the concentration of acetate ion is C whole into 1 minus H. So putting the values, again we know our H is very less than 1. So 1 minus H is nearly equals to 1. So this will be Ka into H. Again putting the value of H from this equation, we can say the concentration of H plus ion is equal to Ka into Kw divided by Ka into Kb square root. So this is will be H plus ion is equal to square root of K into Kw divided by Kb square root. So again pH is equal to minus log of H plus ion. So this will be minus log of square root of Kw divided by Kb. And solving this equation, we can say this will be again log Kw, this is log Ka, and this is log Kb. So this will be pkb and this will be minus log Ka, because we know pk is equal to minus log Ka. So again plus log Ka is equal to minus pk. And we know at 298 Kelvin this Kw is equal to 10 to the power minus 14. So this will be minus and minus plus. So 7 minus half of minus pK plus pkb, or we can say pH is equal to 7 minus minus, that is plus pk minus pkb. So this is the pH formula of weak acid and weak base whose pH will depend upon the value of pka and pkb. If pka minus pkb is a positive value, the pH will be greater than 7. If the pk and pkb, this will give a negative value, so pH will be less than 7. Yes, so stay connected. We'll come up with more examples, more questions. Till then, thank you very much.